Hello and welcome to this pre-recorded event for feedback on June 2015 Methods in Mathematics. To help you get the most out of this feedback, you may want to have the following documents handy, as we will refer to them during the session. Copies of the question papers and mark schemes. Copies of the activity documents. Delegates will receive feedback on national performance of candidates in Methods Units 1 and 2 of the June 2015 examination series, consider the variation of candidates' performance on different questions and possible reasons why, look at the examiner's reports, address common issues and FAQs. We will start by looking at foundation tier. What candidates did well included 1-mark answers, or very straightforward processes, or processes involving money. For example, F1 question 4a, a straightforward likelihood probability task. F1 question 12, selecting digits to achieve largest values. F1 question 21, solving a problem based on Venn diagrams. F2 question 15. Solve a problem involving fractions and percentages of a quantity. F2 question 16. Carry out a calculation using a calculator. Similarly, on higher tier, generally 1-mark answers or straightforward, familiar processes. For example, H1 question 8a, drawing a straight line on a grid given its equation. H1 question 12, probability, including completing a probability tree diagram. H2 question 11, solve a problem involving areas of semicircles. H2 question 13c. Use a calculator in standard form. We shall continue by looking at some specific examples. We start with paper F1, question 21. From the Principal Examiner's report. There were many good answers to this set question, showing that the students had been well prepared to answer such questions. In the Venn diagram, this student has made a slip. The 12 is in the wrong region. The student does show a good understanding of probability when answering Part B. From the Principal Examiner's report. It was also clear that not all students were familiar with the notation used in both parts of B, with confusion over the interpretation of the symbols and words. In this case, the Venn diagram is correct, but the candidate does not understand set notation, getting 0 marks for Part B. Paper F1, question 20. This was a geometrical problem which required calculation of several angles in order to get the final answer. From the Principal Examiner's report. It was pleasing to see many students getting at least the right answer. Many candidates, despite getting the correct answer, did not get full marks. This student has shown good problem-solving skills, but has not provided sufficient reasons to be awarded the last 2 of the 5 marks available. From the Principal Examiner's report. Many students recognized there must be 2 equal angles in triangles CDE, but often failed to spot the equal pair. For example, angle EDC was sometimes marked as 54 degrees. This student did not identify the correct pair of angles in the isosceles triangle. However, they did provide reasons in suitable language for some of the steps, and did earn communication marks. Paper F2, Question 15. From the Principal Examiner's report, which most students found accessible. Although this is an unusual method, all the steps are correct and the final answer is right. Although in this slide the student did not get full marks, there was enough working shown to ensure some marks. The candidate has found the number of yellow counters correctly, but has found 2/5 as a percentage in the subsequent calculation. Perhaps they forgot to multiply the 40 by 4, which would have put them back on the right track. From the Principal Examiner's report, there were a few students who successfully found the number of yellow counters and then found out how many counters were left. They then wrongly concluded that 40% of these remaining counters were blue. This candidate has found 40%, so 2/5 of 256, instead of 400. The next question was common to paper F1 and paper H1. Comments about the performance on each paper is given in the subsequent slides. From the Principal Examiner's paper F1 report. Many students were able to find the value of x either from solving 7x plus 15 equals 36 or by trial and improvement for the sum of the lengths of the three sides. Foundation tier. This candidate gets the first 3 marks for finding the value of x. They then show confusion between perimeter and the angle sum of a triangle. From the Principal Examiner's paper H1 report. The first 3 marks, for setting up an equation to solve to find the value of x, were scored by the majority of students. They were then able to substitute this value to find the length of the base and height for the triangle. Higher tier. A general issue throughout the paper ones was the inability of many students to calculate accurately. From the Principal Examiner's paper F1 report. Although it was not uncommon to see the 3 sides added and 36 again appearing as an answer. Foundation tier. And from the Principal Examiner's paper H1 report, some did not proceed beyond finding x, some only worked with perimeter, and others took 36 as the numerical area leading to a quadratic equation to solve. Higher tier. Especially in F1, the final mark was lost through not knowing the formula for the area of a triangle. You need the accompanying file for Activity 1, as well as the F1 and H1 mark schemes. Use the 2F mark scheme to mark the 5 responses shown to question 18. Then, use the 1H mark scheme to mark the 5 responses shown to question 16. Question 18 on F1. From the Principal Examiner's paper F1 report. A compound volume question which students approached in a variety of ways. The most popular method was to split the solid and find the volume of the cuboids formed. For many candidates, the mark awarded was M1MOAO for finding the volume of one cuboid. You should have seen from the exemplars that many candidates could not split the shape accurately and allowed overlaps. Question 16 on 1H. From the Principal Examiner's Paper 1H report. Dealing with the denominator 4 caused the most difficulties, with some students aware of the need to multiply by 4, but carrying out the process incorrectly. This led to many instances of 2x minus 5 equals 12x plus 1, and some of 8x minus 20 equals 12x plus 4. So 0 marks were common, as candidates could not really get started correctly. Here is another question common to both tiers, this time from Paper 2. Candidates had to produce a table of values, draw a quadratic graph, and then use it. From the Principal Examiner's Paper H2 report. Most students correctly identified the x-intercepts as giving the correct solutions to Part C, higher tier. And a few students gave the coordinates of the turning point rather than the minimum value for y, higher tier, which is what this candidate has done. A common but elementary error was to join points with straight line segments, as here. There is some evidence of curvature here, but it is not clear which graph the student intended. From the Principal Examiner's Paper F2 and H2 reports. The most common error in the Part A table was to give either 1 or minus 3 as the y-coordinate for x equals minus 1. Unfortunately, students making this error did not use the lack of symmetry in the graph they subsequently plotted as a prompt to check their Part A answer. This candidate has also made a fundamental error of giving the x-coordinate rather than the y-coordinate. Candidates were generally competent at using a calculator. For this question, many got the correct answer of 33.64 by working out the numerator and denominator separately. However, many did not use their calculator correctly. From the Principal Examiner's Paper F2 report. Some successfully dealt with the fraction and just gave the correct final answer. This was a high-risk strategy, as no part marks could be awarded for an incorrect answer. The answer shown comes from a direct entry into the calculator, so ignoring BIDMAS. This question requires some mathematical sophistication, as it is essentially an algebraic proof involving the student developing their own representation. From the Principal Examiner's Paper H2 report. An appreciation of two appropriate expressions for consecutive even numbers was essential, and where this was done correctly, students were usually able to go on to pick up subsequent marks. This candidate has it all. They can set up the correct representation, the algebra is accurate, and the interpretation of the final expression is assured. This candidate has some idea of what to do. They go for a simpler representation, but pay the penalty when it comes to a clear justification of the required proof. Some candidates were let down by poor algebra. From the Principal Examiner's Paper F2 report. which led to some errors squaring the 2n with 2n squared rather than 4n squared often given. Activity 2 is concerned with anticipating common errors that students make when solving problems. There are 2 tasks. Task A. Work carefully through F2 question 23, H2 question 11. Make a list of the most likely errors in student responses. Task B. Work carefully through H1 question 23. Make a list of the most likely errors in student responses. Then compare with the responses file. From the Principal Examiners, Paper F2 and Paper H2, reports. However, the usual confusion between circumference and area was seen. F2. The errors that were made tended to involve omitting to use semicircles rather than full circles for all or part of the calculation. H2. There are examples of these and other typical errors in the file. This question was better done by completing the square, but the use of the quadratic formula was more often seen. From the Principal Examiners, Paper H1, report. Sign errors were apparent in much of the work with the formula, and some students did not extend the line under the numerator far enough to the left to include the -b term. And some errors with manipulation and surds resulted in incorrect final answers of 6 plus or minus the square root of 62. There are examples of these and other typical errors in the file. Here is a summary of some of the common issues reported in these papers. Remember that Paper 1 at both tiers was the non-calculator paper. 1. At both tiers on the Paper 1s, many candidates had poor arithmetical skills. 2. Again, Paper 1s. They sometimes chose methods that were correct but impractical because of the arithmetical demands required for their choice. 3. Candidates who provided a short narrative, 1 or 2 words stating what they were finding, did better. 4. There were still many candidates who demonstrated the ability to solve geometrical problems, but who could not give supporting reasons. If you would like to know more about examination statistics, you may find these links of interest to you. Examination Results Statistics. Results statistics summarize the overall grade outcomes of candidates sitting Edexcel examinations. Grade boundaries. This page shows the minimum marks needed to achieve a certain grade for all UK and international examinations. Also refer to the examiner's report, which is available for download with other documents. Some information about changes. New GCSEs for 2015. English Literature, English Language and Mathematics. First Teaching, September 2015. Assessment, Summer 2017. New specifications now on our website. New A-levels and AS qualifications for 2015. English Literature, English Language and Literature, Biology, Chemistry, Physics, History, Psychology, Art and Design, Business, Economics, Sociology and Computer Science. First Teaching, September 2015. Assessment, Summer 2017. New specifications now on our website. And lastly, thank you. We constantly look to improve the training we provide. Please let us know what you thought of the training by completing our online feedback form.